So let's have a look at this question, 2.1.13.
What does it exactly mean by how the acceleration is related?
Oh, you know that they are related by a pulley. That means their velocity are actually related to each other. So and then let's see how their velocity are related to each other. So let's say assume the length of the string to be x1, x2, and x3, okay?
Yeah.
So their acceleration actually is x1 dot dot, x2 dot dot, and x3 dot dot. Okay.
Yep.
Yeah, of M1, M2, and M3. So how are they related to each other? Actually, they are related by the length of the string. So we can say the length of the string is equal to x1 plus x2 plus 2x3. They equal constant. Because the length of the string does not change.
Yep.
So, and then if you differentiate this twice, then you get x1 dot dot plus x2 dot dot plus 2x3 dot dot equal to 0.
Okay.
Then, so these are how their association are related to each other. So let's say if we draw the free body diagrams, they are frictional, okay? That equal to mu m1g tension, mu m2g, and then. So if we write down the Newton's second law, okay, the force, then for m3 it should be m3g minus 2t equal to m3x dot x3 dot dot. Let me write down all the equations first.
Yeah.
So just need to remind you, okay, now why I write t mu m1g minus t instead of t minus mu m1g? Because I let the left position to be positive. you can see this vector are left to the left to be positive. So therefore, I use mu m1g minus t. But why? But can I let the x to be like this one? Actually no, because x1 should be measured from a fixed point. Fixed point. Actually, you can define x1 to be like this. But then x1 is not quite related to the length of the string. So if you want to use this, we call it constraint. If you want to use this equation of constraint, then you should define x1 from this fixed point to the M1 object. Then you can relate the assertion more easily. Okay. So and then that's it for this question. Okay. And then that the remaining is about solving the simultaneous equations. So that's it. So let's go on to the other past paper are actually not that difficult. So let's have a look at this question, this one. This one. Did we talk about this question? No.
No.
So may you try to draw the three-bar diagrams first. So let me draw the two boxes. So may you draw those forces in terms of arrows on the screen. Okay. So you get some mistakes here. So let's say these two, okay? These two are the frictions acting on both boxes, okay? On one boxes on by another boxes. So they are adjacent pair. So they should have the opposite direction. Okay. So let me clear the screen and let's draw. Let me draw it to again here. Actually, the question may be quite confusing. You need to look at the question carefully. It asks you about the minimum compression force that is normal to the block surface. The components only, okay? The components only. So what does mean by components only? That means that there can be and the force F that can also has a component along the slope. Okay. So it can
Okay.
also has a component like this one. I think it's not difficult to understand why the force should be along upwards the slope. Okay. It's not downwards the slope. Then we draw the graph T. Okay. You use a simple mg instead of small g. Because small g means the acceleration, 9.81.
Yeah.
So, and then there is a norm version also, okay? Okay, and then, so then I call this notion to be R. Of course, there's a friction upwards. I call F2 now. So, how about the direction of friction?
I guess for the upper one, it points downward, then the second one upward. Upwards, I mean like along the incline.
So, um, now actually, so how can we reduce the F perpendicular? We want to reduce this one. That means we want to have a smaller friction, F2 or F1. So how can we get a smaller friction here? You need to have the friction here should be upwards. This should be downwards.
Yep.
So this is really a trick question. If no question, then let's have a look. Okay. Then let's have so then let's see how to solve it, okay? And then let me write down all the simultaneous equation. But let's don't waste time for in solving the equations. So for F2 plus F1 equal to mg sine theta. And then F equal n equal to F perpendicular plus mg sine theta. And then R equal to F perpendicular plus 2 mg sine theta. And then F is smaller than mu times n. And then both function will attain the limiting value. That means the maximum value they can have. Okay, and then you try to solve these equations. Then you solve it later on after the lesson, okay?
Okay.
Then you capture the screen and then let's go on to the next question.
You can go on.
Okay, so let's have a look at have you tried to do this question? Sorry. May you try to think about this, how to do this question, this one. We give you 2 or 3 minutes. So do you have any idea to do this question? If no idea, that's fine. So then let's do it together.
No idea.
Yeah. So let's do it together. So in this question, it's quite you need to use the skill. It's about cutting the wire into small parts. So let's do it into this is the top view. Okay? Top view. So let's draw 2 rings here. I can't draw it good. Okay lah. So this is the ring. Okay, this is the top view. So we need to cut it into small parts. So let's say I cut it into small part here. Okay, and then this is a very small angle, theta. And then there is a tension acting on both ring. No question. Then
Question. Yeah.
and then what? So let's have a look at the side view. This is the slope, and then this is the string or the train. So there are also no motion acting on the chain. Okay. And also the weight. So in total, there are 4 forces, 2 tension, and then 1 is non-motion, and 1 is the weight. So can you express the weight of this small part chain?
Because theta over 2 pi times m.
Yeah, so you use the ratio, okay? Yeah, theta over 2 pi times m or times g, okay? And then you try to solve this thing. Oh, I shouldn't use theta here because there is a theta. So let me use the phi, okay? So how can we, if you decompose a non-motion into 2 parts, this is theta, and that means that this one should be 90 degree times theta. This is n cosine theta, okay? So then you try to solve n first, okay? So you get n sine theta equal to this one, then n cosine theta. You should substitute n, the value of n. So n cosine theta will be equal to, n cosine theta, if you draw the horizontal component or the component here, it should be like this. So can you relate the non-motion n cosine theta and the 2 tension and also the angle phi?
Pardon?
Can you relate these 3 quantities? Let me highlight these 3 quantities together using the angle phi. Don't know if and then what you need to do let me draw it clearly here. So cut it into half. So this has an angle 5/2, and this has an angle 5/2.
Yep.
So then how we do it you can write as n cosine theta will be equal to 2t times sine over 2. Sorry, this one should be used to angle phi. Okay.
Yeah.
And then actually you need to use a approximation. So what does this approximation mean? It means that you need to cut it into a very small angle. So in terms of a small angle, then sine phi will be roughly equal to phi. So this one will be equal to t times phi.
Okay.
So if no question, and then so can you find the answer? So what?
D.
Yeah, so that the answer is D for dog. So you need to know how to use this kind of method to do the question. So we can save the screen now, and then let's go on. Save it.
Yep.
So then let me. Actually, there another method to do this question, but let's focus on the method I told you first, okay? Because the solution is shown that you actually use another method, but actually we can. It's rather you use my method first. So then let's have a look at. We do it together last time, or no? No.
No.
So then let's do it together. We have a look at this question first.
Does a smooth plane mean there's no friction?
So let's try to do the question part A. So for part A, they have the everywhere has no friction. So if we draw the 3Y diagram of A and B, so there is a no motion like this, and there's no motion like this. There's force. Also no motion, let's say it's R1 and R2, okay? And there's a weight. That's it. That's the 3Y diagram. So do you know when the F is maximum, what is special about these forces?
They all um
So actually, can you think if the force is very, 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 very large? So what happens to these two objects? What is there any special about these two objects? If the force is very, very, very large,
yes, A would
will slide.
go up the incline.
Yeah, okay. A will slide over B, is it?
Yeah.
So, and if the force is maximum, that means it is about to slide. That means if the F is greater than this value, and then it will be about to slide over over B. So that means that right now, if the F is maximum, then R1 will tend to 0. Or you just consider R1 to be 0. Because when it's lie over B, then there's A is not touching the table. Then there's no normalization acting on A by the table.
Yeah.
Yeah, that's it. So can you find the answer then? And then to solve this equation, and then actually, this is theta. So that means this is also theta. Yeah. So you can see Rn cosine theta equal mg. And then n sine theta will equal ma. And f equal to ma. See if you have any question on these equations.
No.
No. No, right then let's go on. So for part A, okay, you can solve these three equations and then you can get the answer. How about for part B? Find the maximum value of mu such that A and B accelerate together without relative slipping. Now, I think the question, your answer should be expressed in terms of F. No, maybe no. I'm not so sure. But you may solve it too. So in part B, actually, there is a friction. So in the diagram, actually, you just add two more forces, the friction. Okay, and then try to solve it. Then right now, of course, these two equations are not valid. And then you need to add something to this equation. So let me write down the equation again. So that is n cosine theta equal to mg plus mu n sine theta. And then n sine theta plus f cosine theta, f is mu n, equal to ma. For part B, you are solving these three equations. No question.
No.
So if no question, then let's go on. So and then for part B and part C are the same question. Actually, if you can find the maximum value of mu, then you can solve the value of f. Okay. Then let's go on to the next part. How about this one? Can you try to solve this one? This question, this one.
So there's no friction between the blocks and the ground, right?
Yeah. Actually, the question actually we can rewrite the question. So we can say that we can find the maximum f such that this find the maximum f such that they all move in the same assertion. You should understand these two statements are actually equivalent to each other. So these two questions are actually the same. No question. Find it. Let me write down some equations. Now, in this case, you should not assume that the function will go to maximum value because there's two functions here. So you don't know whether which one will go to maximum. But actually, I think this one will go to maximum. Because if you consider the free-wall diagram of this system, the only forward force acting on these three objects is a friction. So that is equal to mu mg, then equal to log 6m a. Eh? I think I get something wrong here. Mm. Eh? Oh, yeah. Okay, no question. So you get the A should be mu g over 6. So that means F equal to 10 times m times mu g over 6. Okay.
Yep.
So you try to do the questions in this PDF, okay? If you think that question is too easy, you can skip that question. But some of the question may, especially for those Indian question, they may require more, they may require calculus. So you may skip those questions first. So you take some time to do the questions first, okay, today. And then you ask me during this weekend. Okay. If no question, then let's end the lesson. Okay. I have to go to have lunch now. Okay. Then see you. Bye bye.
Bye.